Class, we're on part 2 of Unit 16 review. And the next question says, are these triangles congruent? We're on number 7, yes or no. And we have no markings whatsoever on this. So the first thing we're going to do is analyze. And we have to mark given this bit of information here. That's the given. So if PR, segment PR bisects angle QPS, so here's QPS, that's this angle that's right here. Then if PR is a bisector, then this angle and this angle are going to have to be congruent by definition of bisector. So we have one set of congruent angles, and then it also bisects angle QRS, which is this angle right here. So if that angle is bisected, then this angle is congruent to this angle. So we have two sets of congruent angles on either end of this hypotenuse of the two triangles that's shared, and it's PR. And also, because they're shared, then we have by the reflexive property that PR is congruent to PR. And after marking that and analyzing, you can see that we have angle side angle. So definitely, and it's the included side that's between the two angles, right? So that side right there is what we call an included side. Just bringing that up, not that it really matters here, but it is an included side. Well, it does matter because then it's angle side angle and not angle side. Spitting that side out to the side, it's right in between the two angles. All right, PQR. Now I have an arc on P, I have two arcs on R and no arcs on Q. So I have everything marked appropriately. You can come up with my congruency statement with it. So from P to Q to R, we have 1, 0, 2 arcs. So I have to state the same order for my congruency statement. So one arc is P, Q has no arcs, S has no arcs, and then R has 2 arcs, and R has 2 arcs. So that is our congruency statement. All right, next one. Are they, oh, did I say yes? I can't remember. I did not. Okay, mark yes. Okay, next one. Same thing. Are they congruent? And then what's the reason? So, are they congruent? Oh, I'm going to have to move my little face over. Maybe. Can I? Here we go. All right, I just want to see that congruency statement. Okay, so are these triangles congruent? So we have two markings. We have a side and a side. And then we have unmarked, but we can mark that the vertical angles are congruent. So if the vertical angles are congruent and we have a side-side angle scenario, and if you recall, SSA does not work, does it? So we would have to say no. And if they're not, that's fine, but we can't write a congruency statement because they're not necessarily congruent, and we have no reason to say that they are congruent. So this one's a nope. All right, number 9. Are these triangles congruent, yes or no? All right, let's analyze. First thing is to analyze, figure out for sure if they are and why. And we have a side marked, and we have a right angle that's congruent, and we have a reflexive side. Remember these little reflexive sides. They are congruent to each other because they're the same side, but they're a shared side. All right, so we have side-side angle again, right? Isn't that odd? We have side-side angle, but we have a right angle, and we have a leg, and we have a hypotenuse. So with a leg and a hypotenuse and a right angle, then yes, they are indeed, that's Y stands for yep, they are indeed congruent. That's because we have the HL theorem, hypotenuse leg, which only works for right angles. And consequently, I hope everybody watches this because I usually tell the class this as we're moving along, and it's hard when I don't have you here, but the HL theorem with the right triangles is the only theorem that says triangles are congruent that's a side-side angle. It is a side, and an angle. However, because it's a right angle and we have a hypotenuse and a leg, then in this case, the two triangles must be congruent by HL. All right, so we have an E, a D, and an F. Now, I only have one angle marked, and that's kind of a hard way to set up everything. So I'm going to just mark this little pointer angle right there. So it's the angle between the two dashes and the 1 dash. So over here between the 2 and the 1 dash, I have this angle, and that will at least help me line up my angles a little easier for my congruency statement. So if I have E, no arcs, and then no 91, then that's what EDF is, no arcs. E and G has no arcs, so we're going to line up G. And then D is second, and it's the 90-degree angle, and as is F in the other triangle. And then one arc here is F, so the other one is D. And that's how you set up your congruency statement. Okay, we've got a couple more to do here. Are these triangles congruent? So again, we're going to analyze. Now, we have some information that we're given, the two sides that are congruent, but we have only two sides, and generally in all of those shortcut methods, we need three. But we are given this little bit of info here that says that those lines are parallel. So let's mark those in blue. CE is parallel to FG, all right? That's good information. I'm going to draw the arrow so we see that. Now this then becomes a transversal for the two parallel lines, and we know that corresponding angles that are attached to the transversal are congruent. So now we have a side angle side scenario, side angle side. So yep, they are. That one's a big yes, and the reason is side angle side. And do we have enough information? I don't know that we need to really mark them, but these are because it's just a slide. They're not rotated or reflected or any crazy things haven't happened to them yet. So they're just slid over, but it's very easy to come up with our congruency statement. We have CDE, which is 2, none, 1. So we're going to go 2, none, 1. G, E, F. All right. All right, next one. Are these triangles congruent? So M is the midpoint of AB. That's the information we're given. Now, remember that given information helps us to analyze. Specifically, that M is the midpoint. That means these two sides have to be congruent if M is the midpoint, by definition of midpoint. And then we have a reflexive side that's congruent to itself by the reflexive property. And indeed, we have a side, side, side. So they are congruent by side, side, side. That's the reason. Yes. And then we line up angles. Now we have no angles that we know of. The pairs that are, we know they're congruent, but we don't have them marked, and we need to know what's congruent to A. So A is between the 1 and 2. 1 and 2. Between the 1 and 2 over here is B, so we'll do B. M is between 2 and 3. And so between 2 and 3 on the other side is M. And then C here is between the 1 and 3 arcs, or dashes, so that's going to be congruent to C. All right, doing great. Now we get to hit the proofs. Woohoo! Yay, proofs. All right, I'm going to make this a little smaller so it's possible to fit the whole thing on one page. Ooh. All right, so first thing we're going to do is analyze. Given AC bisects angle BAD, BAD, and angle BCD. So you're given that. Let's mark that real quick. If AC is a bisector of the two angles, first is angle BAD, which is right here. So that means those are congruent. And BCD, these are congruent. Okay? And that's all the information we're given. And that's all we need, because we also know that these reflexive sides are congruent. So with that information, we can state the given, and we know that they're congruent. We're trying to prove they're congruent, and we can do that using what? We're going to use angle side angle, aren't we? It's an angle side angle. So an angle, a side, and an angle. Awesome. So first we state that AC bisects angle BAD and angle BCD, and that's given. The next thing we're going to state is angle BAC is congruent to angle DAC, and that's the angle on the left, the angles that are created by AC bisecting BAD. And then by AC bisecting BCD, we have angle BCA is congruent to angle DCA, and that is by definition of bisector. All right, and that gives us the two angles. So with the two angles, all we have left to state are that the side AC is congruent to AC, and that is by the reflexive property of congruence. And then that culminates all the sides and angles that we need for angle side angle. So we can now state that angle or triangle ABC is congruent to triangle ADC by angle side angle. All right, so that's that proof. I think I have enough time to finish the second proof, 13. So BC is parallel to AD. Again, we need to mark those. BC is right there, is parallel to AD right there. And we have this side parallel to that side. Now, with that, the only thing that we have that creates angles, a transversal and an angles that are congruent is this transversal right here, because this angle is tied to only the parallel line and the transversal, and this angle is tied only to the parallel line and the transversal. So that gives us those two angles are congruent. All right, we also know from the given angle A is congruent to angle C, and that the reflexive side BD is congruent to itself. So with those three items, we have an angle, side as we go around. We hit an angle, and then a side. So it's going to be an angle, side that they're congruent. Now, once we prove they're congruent, then we can prove what we need to, that side AB, here, let me mark it in red, AB is congruent to side CD. Those are the only two things we know to be, or we know those will be congruent because they are corresponding sides of two congruent triangles. So we'll just have to apply that. So number one, we're going to state that BC is parallel to AD, and that's given. From that information, we got a couple of congruent angles. So the congruent angles we got were angle CBD is congruent to angle ADB. Right? And that is by the fact that they are alternate interior angles. All right, the next thing we can state is the rest of the given. Angle A is congruent to angle C because that's given. And so far we have two angles. We need the side. The side is side B, let's see, BD 1 to none is congruent to, we need to go 1 to none, so DB. And that's by reflexive property of congruence. And then because of that, our triangles are congruent. Now we have to be careful when we state these because they've been rotated. So triangle, let's go no arc, 1 arc, 2 arcs. So BDA is congruent to triangle none 1, none is D, 1 is B, 2 are C. All right, and that's by angle, side. And then because they're congruent, then corresponding sides, AB will be congruent to CD by CPC/TC. Okay, and that's 13 minutes. My guess is we're done here and we have more proofs, and that might take a little bit longer. Whew, got 4 more proofs to do. That should be a good next video. So we'll start right there. Okay, move on to part 2. Can't get over there to stop it. There we go.